all, good morning, everyone. I hope you all are enjoying the conference so far and have been collecting a lot of information in Python and other stuff, right? And thank you for Adam and his team. For putting together it's a great conference. I hope everyone take away some important things out of this conference. I'm Gokul Prabagaren. I come from CapitalOne and particularly part of a rewards organization. I'm here to talk about the lessons we learned, our experience while building a cloud native platform, which right now processes billions of customer transactions. And those are the things I'm going to share as our discussion topic today. So before we start, some details about CapitalOne. CapitalOne is the first US bank to exit out of on-premise legacy data centers and go all in cloud. And we have done this successfully in 2020. That has been a multi-year journey. And since 2020, for the past 2 years, we have been operating all our workloads 100% on public cloud. We happen to think as a tech company because that's how we do all the stuff and that's how we operate. And this is the way we actually think. We are a tech company which happens to be in a banking business. So CapitalOne is a tech company which primarily does banking business. And we are a founder-led company today, and we are on our mission to change banking for good. So we do sponsor a lot of community efforts, and particularly when it comes, because this is a tech conference, in terms of tech, right? We open source a lot of our things, whatever we do internally, about 20 plus projects, particularly to call out few, like Critical Stack, which is a security focused Kubernetes offering, Rubicon, which is a YAML tracking, whatever the executions you did, it's a tracking tool, and Data Profiler, because it's a Python specific one, so I wanted to call out that as well. Data Profiler is another open source which we did recently. It is a Python library designed to make data analysis, monitoring, and identification of sensitive data, this detection easy. And also, we sponsor a lot of programs. I have called out few in particular. The reason is that's the way we actually give back to community, right? So one such of program is Coders program, which is primarily operated in middle schools across United States. This inspires our future generation by educating, by mentoring, by empowering students to recognize their potential as future technologies. Another program to call out is CODA, which provides a pathway for non-technical aspirants to take up a tech career so that they can be on the tech. So those are the few things. So comprising that, just wanted to, before we really get into the meat of this conversation, some details about CapitalOne. Right, so this is the agenda for this presentation. First, we will start with a quick refresher on Apache Spark, Cassandra, and MongoDB to level set the field. So we may have variant audience. So I wanted to just a quick refresher on what are all the things we are dealing in this and how these are all connected with a refresher. Right, then we will see what rewards platform architecture looks like in CapitalOne at a very high level, right? 10,000 foot view of what architecture looks like and how all this technology plays a role in them. Then I would like to take you all on a trip to Cassandra land and Mongo land in imaginary TCP/IP Spark. I hope that will leave some time with a Q&A. So let's get started. So Apache Spark It's a widely adopted in-memory parallel processing framework in big data world. So if you are from data background, Apache Spark is very well known in the field. Right? So typically Apache Spark is made up of a master node, a driver node, and bunch of executors. Once your big data processing is submitted to the master, depending on your mode of operation, driver is decided, and driver, whenever a particular action is performed, it asks the executors to compute the transformation. That's how it parallelizes the execution. So that's the high level details on how Apache Spark infrastructure works and how it computes things and then does all this big data processing. And Apache Cassandra is widely used columnar NoSQL database. To call out few specifics about that, it doesn't follow primary, secondary model, which typically used in a lot of databases. Cassandra doesn't follow that. All the nodes are same. And where it majorly differs from RDBMS or any other database, it's in its use case driven modeling. Partition key defines the data access pattern, and that's how the entire row in your columnar storage gets pulled. So that's the key difference when it compared to other databases for Apache Cassandra. And MongoDB, which is a widely adopted another NoSQL, which again follows the primary secondary structure in comparison with Cassandra. But the main difference when it comes to the MongoDB or what it offers is it's schemaless document design. So it stores all the information in its collection as JSON. You may be wondering why I'm just refresher. Let's probably connect these things once we go through the architecture. So this is the rewards platform's high-level architecture. I would say 10,000 foot view of what we do in CapitalOne. If you have used or if you have owned any of CapitalOne credit cards, CapitalOne is obviously known for its credit cards. So this platform is responsible for processing those and providing earn for those transactions. Let's say before you stepped into today's session, you picked up some coffee on your way or you did something on our credit card. Everything flows through this platform. So on a very high level, we receive customer transactions and then we compute earn by looking at those transactions. It's a abstracted black box is what I have shown. It goes through a lot of processing internally. Those are all done using Apache Spark, and we persist all those information about customer earn and their transactions in Cassandra and MongoDB backend. So that's how this all things connect. And this platform processes over 1 billion of transactions every year. And in turn, it actually provides the rewards back to the customer. So it has a positive impact on customer life. Then with all those context on our application, technology, and the data stores, I think we are ready to start our adventurous journey in TCP IP Spark. First, we will begin our journey exploring Cassandra land and gather some valuable tips. Famous ride in Cassandra land is token ring Ferris wheel. All the customers who are riding the Ferris wheel, their details are captured in Cassandra like this. And there is a season pass holder, Mr. Doe, who has gone missing, and park security is trying to find his whereabouts. And they are using a query like this. And seems like the system is not happy and it is responding like this. Why did that happen? The lesson here is Cassandra key sequence while querying matters. By the inherent nature of how Cassandra partitions the data in the disk, if the key sequence is not followed, it will not be able to fetch the data quickly from its partition. Instead, it has to do table scan, which in terms of any database or any application processing, if you're doing table scan for each and every query, that may put a lot of strain on your backend. So in our case as well, that was actually causing strain on the database cluster, and that is why we were seeing like this. So if you have noticed, Park Security was trying to query using the keys in a different order. That's not how the Cassandra is defined. So now they have realized and they have corrected it. So using this query, now after correcting the sequence, they're able to find the whereabouts of Mr. Doe. It seems like he has gone to the gift shop to buy TCP/IP Park souvenirs. It's always important to get souvenirs to remember your park visit, just like how it is important to mind your Cassandra key sequences. Another popular ride in Cassandra land is partitioner roller coaster. If you select the correct seat, also known as partition key, you will be able to get back to the base station in exhilarating milliseconds, also known as querying. While customers are enjoying their roller coaster ride, their information is persisted like this. It is important because, like most roller coaster rides, partition roller coaster in Cassandra land also provides lockers for keeping your things safe while you are on the ride. But some customers might like to keep things close by, or they are in a hurry to board the ride and forget to use the lockers. If you are one of those person, or if you're like me, sometimes I also do those things. It's easy to fall out of your package, or you probably may be so excited to get onto another ride and you forget those things, whatever you had. So whenever roller coaster operator finds something under the roller coaster seats, in any of those seats, there arises a need to find all the riders who took the ride on that day. So this is the roller coaster's need. While it is possible to find the information from the customer schema, but it is not optimal to do in Cassandra terms. If Cassandra is considered actually as an anti-pattern, because Cassandra data is partitioned and its use case defines the schema. So how you are going to fetch the data out of the database for your use case. So that's where it primarily differs from any other data stores. So your use case defines your schema. And the lesson here is you actually have to design your schema in first place depending on your use case. That's what called as actually use case driven modeling. In case if you need the data as the usage evolves or some other need arises, and then the data producer actually has to duplicate the data, you may not be able to retrieve out of the same table you have already created. That table is specific for that use case, and you will be able to pull the information only using that particular key. So the lesson here is design your schema based on your use case before you begin the development. I hope you were able to gather some valuable information along with some important souvenirs from TCP IP Spark, now we are heading into a much awaited Mongo land. While customers are going round and round on their schemaless carousel, their information in the backend is stated like this. From our visit to Cassandra land, you may remember Mr. Doe, who is already a season pass holder to TCP IP Spark. Seems like because of his continued attendance, he got bumped up into a even more higher membership tier, and we need to process his update to the system for his upgrade in the membership. But in order to process that information, the carousel has to stop, and the other riders are unhappy because it's being slowed or it's being interrupted. When we try to process those updates for Mr. Doe, seems like the system is giving error like this. It seems like even it has gone down. The lesson here is MongoDB connections, when particularly doing with the Apache Spark, it has to be handled at the JVM or partition level. If the connections are not handled properly at the partition level, there is a possibility that your application may open a lot of unwanted connection, particularly when you're dealing with this kind of high volume of processing. Then the lot of connections it opens may not be able to do if you're dealing that at the wrong place in Apache Spark code. So it has to be always dealt at the partition or JVM level in Apache Spark code. And I have just provided a snippet showing where it has to be done. Because this has the potential to even bring down your database, and in turn, maybe your database cluster, making all other carousel riders unhappy. Moving on, after recovering from the schemaless carousel debacle, we haven't still processed Mr. Doe's membership update. We are making another attempt to do while we get the spinning Ferris wheel, or in this case, carousel again, just like our visit to Cassandra land. Seems like, again, the update hasn't gone through. Seems like Mr. Doe's update is not even making, he's definitely unhappy. The lesson here is, if you have noticed, MongoDB indexes are very important. And they are even helpful in the cases where you may need to find and update information specifically, like Mr. Doe's part membership status update. Because if we are not specifically identifying and then processing the update, similar to whatever happened in the Cassandra layer, it may be doing table scan for each and every find and then update. So indexes play a very key role in those kind of scenarios when you're dealing with high volume of processing. So make sure you have correct indexes in your MongoDB while you are dealing with the high volume of processing. I hope you had enjoyed your trip to Cassandra and Mongoland in TCP IP Spark, and you were able to gather some valuable souvenirs, so known as tips, from our imaginary TCP IP Spark and Cassandra land and Mongoland. So before we adjourn, some details about me. I'm an engineering manager at CapitalOne. I have been doing a lot of Spark related things, and I have predominantly involved in building this platform. And I have contributed to actually Spark related things. I have been dealing with the applications from initial versions of Java and Spark. And I contribute to CapitalOne's tech blogs, particularly on the topics of Spark or distributed computing, a lot of new SQL offerings, those kind of things. And I have provided my handles on LinkedIn, Twitter, and Medium. If you like to connect, reach out to me. What's in your wallet? Thanks, everyone. If you liked what you heard and want to be part of the same platform which processes high volume of sections yearly, we are hiring. Reach out to me.